Okay, once again, you're welcome to our online lesson, Math Made Easy with PDY. We've started a series of sessions on the topic binomial expansion. And in our previous lesson, we found out that we can use the combination tool to work out some questions on binomial expansion. So today, we are going to solve some WASI standard questions on binomial expansion, and then we'll move on to how to expand rational exponents and then negative exponents. So stay glued to your seat. Where you have questions, please ask them as we move on. So without wasting my time, let me go to the first slide, which shows that using the binomial theorem, expand and simplify 1 plus half x all to the power 8 as far as the x cubed term. Then B part of the question says use your expansion in 1, which is here, to evaluate 1 plus 0.05 to the power 8. Correct to 5 decimal places. Correct to 5 decimal places. So this is a very nice question. We've learned how to expand this, but we've not done any example which requires us to evaluate a given number. So that's what specifically we'll be doing today. I'll take a couple of questions, you do the others later on. Okay, so based on whatever we've studied so far, we found out that if I'm given any expansion of 1 plus, let me use this color. So we have 1 plus half x all to the power 8. You are not limited as to what method to use, but with this question, I believe because it's a positive index, using the combination formula will be very easy. Remember, the combination formula was given as n combination r. Then we have a to the power n minus r, and then x to the power r. Remember this. That's what we used. So we are going to write each term based on what we have here. As long as the index is a positive number, this formula can be used to write the expansion. And we are going as far as the x cubed term. X cubed term is the same as what term?
Fourth term.
The fourth term. Very good. Very good. That's so excellent. So writing the expansion, then that is going to, since we have n as 8, is going to be 8 combination 0 multiplying 1, because the a value is 1, raised to the power 8, then multiplying half x raised to the power 0, which is the r value. Then we have plus 8 combination 1 multiplying 1 to the power 8 minus 1, which is 7, then half x all to the power 1. Then plus 8 combination 2. So get your calculators ready. You'll be helping me out with the expansion for that. Then we have 1 to the power 6, and then half x all to the power 2. So 1, 2, 3. We are left with the fourth term. That is giving us 8 combination 3, and then 1 to the power 5, and then half x to the power 3. Good. So help me out with that. 8 combination 0, I know is definitely 1. Multiplying 1 to the power 8 is the same as 8. Half x all to the power 0 is the same as, sorry, here is 1. 1 to the power 8 is 1. Then here is giving us 1 as well. So that's what we have here. Plus 8 combination 1, what's the answer? Yes, let's go.
8.
It's 8. Then 1 to the power 7 is the same as 1. Half x all to the power 1 is the same as half x. Then plus 8 combination 2, what's the answer?
28.
28. 1 to the power 6 is 1. And then half x all to the power 2 is the same as 1 on 4x squared. plus 8 combination 3, what's the answer?
56.
56. 1 to the power 5 is 1. And then half x all cube will be 1 on 8, then x cube. So this is what we have, because we are going as far as the s cube term, and that's where we end over. But you have to include the continuation value. So this is giving us 1 plus that is giving us half multiplying 8 will be left with 4x, and then over here 28 on 4. When you reduce it, what are you getting? 28 on 4. So you have 7x squared. Good. Then finally 56 multiplying 1 8 s cube. What do you have?
7x.
7x cube. Thank you. So this is where we can end, and that gives us the expansion for the binomial term up to the s cube term. That's where we end. Then now it says we should use our expansion in 1 to evaluate 1 point that to the power 8. So the whole issue is that now how do we get the s value, because we have to use whatever we have here to answer that. So we need to find out what s value we need to substitute into this, and that will make the question perfectly answered. So this is how you go about to work out your s value. Since we have the inner bracket here to be compared to that, because the 8 and 8 are the same. So to get your s value, just select the inner factor here, which is 1.005, equate it to the inner factor you have for the question, original question, which is 1 plus half x. Then trying to solve for the value of x, then we need to work out x. So you generate an equation and solve for x. Therefore, we have to transpose this one to join the left hand side. That will give us 1.005 minus 1 equal to half x. Are you following what I'm doing here?
Yes, sir.
So when we
Yes, sir.
subtract 1 from that, it will be left with 0.005. I hope you are clear. And that's giving us half x. Are we okay with that?
Yes, sir.
So how do we get the s value? What must we do to get rid of the half?
We multiply both sides by 2.
Perfect. So multiplying both sides by 2, we are going to have 2 into bracket 0.005 equal to x. So s value will be what number?
0.01.
So 0.01. Perfect. So it means that the s value that we need to substitute in order for us to evaluate this is 0.01. Therefore, you can write your 1.005 all to the power 8 to be equal to 1 plus 4 into bracket 0.01, then plus 7 into bracket 0.01 all squared, plus 7 into bracket 0.01 all cubed. Or another person could have also said that then this expansion, the 1.01, could have been written as 1 plus half into bracket where is the value? Yeah, 0.01, then all to the power 8. Then the person will continue up with whatever I've written here, so that you know that the s value that is being substituted is a 0.01. It's still understanding to get it done. So please, going further, 1 plus 4.0, 4 times 0.01, what answer do we have?
0.04.
So 0.04. Then plus this one, programming it is going to give you 0.01 all squared times 7 directly. What are you getting?
0.0007.
All right. So 3 zeros with a 7, right?
Yes, sir.
Then final one, 7 multiplying 0.01 all cube.
0.000007.
How many zeros?
5.
5 zeros. Okay, so this is what we have. So finally, putting all together, just add them. 1 plus this, plus that, plus that.
1.040707.
Okay, so this is our final answer, but we are asked to leave the answer to 5 decimal places. So to the 5th decimal place, that is going to give us approximately 1.0407. 1, 2, 3, 4, and 1. So that is up to 5 decimal place or places of decimal. Please, are we all clear with the presentation I've made here?
Yes, sir.
Any question on that? Any question? Any question? Okay, no question, I guess. So that method we have here, please, can be used to work out other complicated examples, which includes what I have here. So take a screenshot. You do that. Give me a feedback. Have you done that? Then again, you have other examples like this one. That's another example. But I'm going to work out this with you in the shortest possible time, and then we can move on to today's lesson. It's very, very key for you to know how to go about this. Please, are you ready for that? Because this is just an application which it's going to lead me to what I'm going to teach today. It's good for you to understand that. Are you ready for this, please?
Yes, sir.
Yes.
Okay, so we are told that if the first 3 terms of an expansion, this is giving us what we have here. Find the values of n and p. Ideally, 1 plus p x all to the power n. We actually don't know what the n value is. We don't know what the p value is. So we need to look out for those things using whatever we have here. So remember, we learned that if we want to use the combination formula, please, this is leading me to the lesson for today. That's why I want us to be careful with what we are going to do right now. So don't let anything distract you and follow what I'm going to teach right now. Having 1 plus px all to the power n, it means when I consider the rule n combination r, a to the power n minus r, and then x to the power r, then the question now is, what then is my probably n value? N value will be what from here? Yes, what will be n value? It's still going to be n, right?
Yes.
Yes.
But what will be the r value? We don't know the r value. R value is going to be, sorry, we know the r value because the r value always starts from 0, 1, 2, and goes on and on and on. Because the r value being 0, then it means you are writing the first term. R value being 1, you are writing the second term. R value being 2, you are writing the third term. And then it goes on and on and on. So using our n as n and r value as 0, 1, 2, and what will be our a value? A value will be what from this expansion? A value will represent what here?
So 1.
1. And then what will be our s value? S value be going to be represented as what here?
PX.
Thank you. So let's do our substitution, and that's going to give us the first term to be n combination 0 multiplying 1 to the power n, and then multiplying px to the power 0. Agreed?
Yes, sir.
The second term, yes. Can someone quote the second term for me?
N combination 1.
Continue. Let's go fast. We don't have time.
1 raised to the power n minus 1.
N minus 1. Good.
Px raised to the power 1.
Thank you. The third term, quote it.
N combination 2.
Mm-hmm.
1 raised to the power n minus 2.
Good.
Px raised to the power.
Good. Perfect. So it means whatever we have here is the same as the 1 plus 20x plus 160x squared. But we can add plus dot 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 because it goes to infinity. Going further, now n combination 0. Remember we learned that the combination statement n combination r mathematically means n factorial over, yes, quote it,
N minus R all factorial.
n minus r.
Factorial.
Perfect, good. So we are going to apply that here to write that expansion. So you are going to learn two things over here, please. Learning two things here. So that is going to give us n factorial over n minus 0 all factorial and then 0 factorial. Now, for the sake of time, let me do that quickly and then we'll just quote the others fast. Now, n factorial over n minus 0 all factorial. Ideally, I'll be cleaning it, so please watch. We'll have it as n factorial over n minus 0 is the same as n factorial. And then multiplying 0 factorial is the same as 1. So at the end of it all, n factorial divided by n factorial, the final answer is 1. Please, you agree? Because it's like 2 divided by 2. The answer becomes 1. Are you clear?
Yes, sir.
Okay, let's go to the
Yes,
next
sir.
one. We'll be simplifying n minus n combination 1. N combination 1, 2. So this is representing n combination 0. This is representing n combination 0. Take note of that. And the answer for n combination 0 is 1. Let's go to n combination 1. N combination 1 ideally is n factorial over n minus 1 all factorial and 1 factorial. 1 factorial. Are you with me?
Yes, sir.
Good. But n factorial, actually 1 factorial is the same as what number? 1 factorial.
1.
It's 1. Good. So it means we can go further and simplify n factorial over n minus 1 all factorial. So that's going to give us n factorial over n minus 1 all factorial. We know this one is giving us 1, so we don't need the 1 again. But how can we simplify this? Now, if we should try to expand n factorial alone, yes, just give me a few of the expansion for n factorial. N factorial, how can you write the factors for it? It will be what? N times
minus 1.
n times n minus 1. Very good. Now, do you see that this n minus 1 is the same as n minus 1 down here?
Yes, sir.
So instead of
Yes,
going
sir.
all the way to times 2 times 1, we can end over here and say that it is n times n minus 1 all factorial. Then divided by n minus 1 all factorial. So it means that at this point, n minus 1 all factorial will cancel n minus 1 all factorial. So what is left?
N.
N. Very good. So what it means is that generally n factorial, n combination 1 is the same as what answer?
N.
Thank you. Can I move on?
Yes.
Okay. Let me pause over here. If you have a question, you may ask. Let me clarify because we are launching into the deep. Okay, so let's go to n combination 2. N combination 2, ideally, yes, what will be the expansion for n combination 2? What are we having?
N factorial over n minus 2 all factorial 2 factorial.
Perfect. Okay, so in this case, how can we write the expansion? We want to simplify this. So how can we write the expansion for n factorial all over that to make it simple? What can we do? Expanding n factorial, what is it supposed to be? The factors will be what?
N times n minus 1.
Very good.
Times n minus 2.
And this n minus 2 is at the denominator here. Do you see that?
Yes, sir.
So we can end up our expansion for the numerator and add factorial to this. All divided by n minus 2, all factorial, then 2 factorial. Ideally, n minus 2 factorial will do away with n minus 2 factorial for the numerator, and we are left with what?
n times n minus 1 over 2 factorial.
Thank you. Thank you. Thank you. Thank you. Can you guess what n combination 3 would have been? Can you guess? Look at it carefully.
That
Can
is
yeah,
n times n minus 1 times n minus 2 all over 3 factorial.
perfect. This is wonderful. So it doesn't mean you should chew it. If you understand it, it's easier to remember. So it's just a rule that is being generated from one point to the other. So please never chew this formula. Understand it and quote it passionately. And quote it passionately. It's very, very key. So now that we've understood how to write the expansion for n combination 0, n combination 1, n combination 2, which we've simplified over here, now we can go back and write our other things. So let me clear all that I have here, and then we continue. So this is well understood, because in the exams you don't have to show us all these calculations, but you can just go straight ahead and quote it. So going further, n combination 0 has been seen to be 1. Then again, 1 to the power n. 1 to any number raised to any power is the same as 1. Do you agree?
Yes, sir.
Yes, sir.
And then px all to the power 0 is the same as 1. Do you agree?
Yes.
Yes, sir.
Beautiful. Now, we've seen that n combination 1 is what? What's the answer for n combination 1?
n
N.
N.
Very good. Then 1 to the power n minus 1. What's the final answer for that? 1 raised to the power n minus 1. What's the
1.
answer? Is the same as 1. Thank you.
1.
And then px raised to the power 1 is the same as px, right?
Yes.
Good.
Yes, sir.
Then plus n combination 2 has been seen as what? What's the value for n combination 2?
n times n minus 1 all over 2.
All over what?
2 factorial.
Okay. All over 2 first. Then times 1 to the power n minus 2 is the same as 1. And px all squared will give us what?
P square S
p
square.
square.
Beautiful. Then plus dot dot dot. Any question on whatever I've written here so far? Because we are almost through. All right.
No, sir.
So what are we having here? 1 times 1 times 1, we have 1 plus this is going to give us pnx when you expand it, and this is going to give us plus n times n minus 1 all over 2 factorial. We can maintain it as that, and this is going to give us p squared x squared. All right, remember we are told that the expansion of this, the first 3 terms, actually I've written the first 3 terms, is compared to 1 plus 20x plus 160x squared. So it means we must compare this to 1 plus 20x plus 160x squared. Therefore, in order to compare, you compare them based on coefficients of x. We have 1:1, but we can have pnx is the same as 20x. Therefore, the coefficient of x here is what? What's the coefficient of x here?
PM.
Pn.
Pn.
What's the coefficient of x here?
20.
20. So we've generated one equation, that is equation 1. Now, over here, what's the coefficient of s squared? The coefficient of s squared is what?
P square.
What's the coefficient of s squared here?
n into bracket n minus 1 over 2 factorial p squared.
Thank you. So that is the coefficient of s squared. And it must be compared to the coefficient of s squared, which is here as what number?
160.
160. Good. So that is equation 2. So you solve the two equations simultaneously, then you get your answer to the question. And to make it easy, I'm losing much space, but I'll manage it. To make it easy, I believe substitution method will be very easy to apply. And substitution method, then we can say, let's make n the subject from here. From equation 1, n will be equal to 20 on p, right? Do you agree that n will be equal to 20 on p?
Yes, sir.
So substitute n into equation 2. So going further, substituting n into equation 2, wherever we see, or we should have rather substituted for, let's make rather p the subject so that the substitution will be easy. Let's go the other way around. Any of them will be right, but I just want something very simple for all of us. So let's rather make p the subject so that we just substitute once. So making p the subject, p will be equal to 20 on n. So substitute p into equation 2. You know, p is there only once, so that we can substitute just once. That'll give us n times n is n squared. Then we have minus n all over 2 factorial is the same as what number? Yes, 2 factorial is the same as what?
2.
2. Then we are substituting for p, so we have p squared being 20 on n all squared. Do you agree with what I've written here? And this must be equal to 160. I believe you are getting that. So
Yes, sir.
going further, that will give us n squared minus n over 2 multiplying 20 squared is 400, right? All over n squared. I believe you are right.
Yes, sir.
Then equal to 160. We're almost there. We're almost there. Don't worry. Now the 2 can go into the 400 and it will be left with what?
200.
200. So we have
200.
n squared minus n over n squared, all multiplying 200. All multiplying 200. And this must be equal to 160. Are we okay?
Yes, sir.
So at this point, how do we solve for n? How do we solve for n over here? Let me move this to another page. Good. I have a page there. So let me just cut this. Let me cut this. Okay, I'll just code it directly. N squared. So we had, sorry. So we had n squared minus n all over n squared, then times 200 all equal to, 200 all equal to 160. So at this point, yes, what must we do to get the value of n? You can multiply through and you have it as n squared minus n all times 200 equal to 160 n squared. Do you agree with what is here?
Yes,
And
sir.
in that case, you have 200 n squared minus 200 n equal to 160 n squared. It's become a quadratic function you need to solve, and I'll give you 200 n squared minus 160 n squared minus 200 n equal to 0. Now 200 n squared minus 160 n squared will be left with what I think is 40 n squared minus
N squared.
200 n equal to 0. I believe It's just a two-term expression, so we can factorize. When we factorize, what's the common factor?
40.
40, n is a common factor. Then we have n minus, yes, what do you have here?
5.
5,
5.
and that should be equal to 0. Are you okay? So
Yes.
40
Yes, sir.
n must be equal to 0. N minus 5 must be equal to 0. So solving for n here, n is equal to 0, or n is equal to what here?
5.
5.
5. Perfect. So now that we have n as 0 or n as 5, then we can go for p. Going for p, in our previous slide, we saw that pn is equal to 20. So having pn equal to 20, and we have n as 5 or 0. So substituting p times 0 should give me 20. So this one becomes undefined. Here becomes undefined, because you can't solve for p when n is 0 from here, right? Isn't it?
Yes, sir.
But we can solve for p when n is equal to 5, then we can solve for p. So we are going to have p times 5 equal to 20. So p will be equal to 20 on 5. And p is what value?
4.
Perfect. So from whatever we're given, the first three terms of the expansion this in the ascending powers of x is that finding the value of n and p. We've seen, therefore, from here, n must be 5, and then p will be equal to 4 for the expansion to be true. Please, are we okay?
Yes, sir.
So please, we've used one stone to kill two birds. We've been able to generate the expansion for n combination 0, n combination 1, n combination 2, and we've been able to predict for the subsequent ones to come. And we've used it to answer a question of this kind. So it's going to make our work easy for today. It's going to make our work very easy for today's studies. Kindly take a screenshot of this, take the next one, then you can take your time and go over it again. But I believe I've made it well understanding. I didn't want you to chew any formula, but you should be able to quote it wholeheartedly. All right, take a screenshot of this one as well, so that for the sake of revision, you follow through. All right, so if that is done, we've seen, then this is what we must bear in mind. If I have, let's say, 1 plus x all to the power n, whereby n is a rational number. Please look at this carefully. I could have made it a. Let me make it a. It doesn't matter. And from a, we can change the a to become 1. Then what will be the expansion for this up to some terms? This is going to be as n combination 0 multiplying a to the power n multiplying x to the power 0 plus n combination 1 multiplying a to the power n minus 1 and then x to the power 1 plus n combination 2 multiplying a to the power n minus 2 multiplying x to the power 2 plus dot dot dot. Let me just end here. I don't want us to go so far. So we've learned today that n combination 0 is the same as what?
1.
Then we have a to the power n. This is a variable, so automatically a to the power n is the same as a to the power n. But x to the power 0 will be given as 1. Then plus n combination 1, we've seen it as what? Yes, what's the expansion for that?
N.
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 Then you have a to the power n minus 1, because you can't do anything about this because they are all variables. Then x to the power 1 is the same as x. Then plus n combination 2 is the same as what? Expansion.
N
times
times N minus 1
n minus 1 all over 2
over 2.
factorial.
2 factorial. Then we have a to the power n minus 1. Sorry. N minus 1. Then times,
10 minus 2.
pardon? Oh, sorry. N minus 2.
N
N
minus
minus
Then times x squared. If I should add the third term to it, then it's going to be n times n minus 1 times n minus 2 all over 3 factorial times a to the power n minus 3, then times x cubed. Let me bring it down here. If I'm adding the third term to it, let me just bring it down. I'm being lazy on that. Sorry. If I'm bringing the third term to it, it's going to be n times n minus 1 times n minus 2. So you have 3 factors here all over n, 3 factorial, then times a to the power n minus 3, then x cubed. If I should add the fourth term to it, then it means I should have 4 factors at the numerator. So it's supposed to be n times n minus 1 times n minus 2 times n minus 3. Have I gotten 4 factors? Yes. All divided by 4 factorial times a to the power n minus 4, then x to the power 4. My people, are you with me? So
Yes, sir.
this is how you should be able to quote it wholeheartedly. You should be able to quote it wholeheartedly. So in this case, watch this carefully. In this case, if I change the a to become 1, if I change the a to become 1, this formula, as you see here, can be used for whether n is a negative number or a rational number, because when you simplify it into the factorial form, it makes it easier for you to expand. So whether it's a negative number or a positive number, you can work it out, because remember, the combination formula to program on your calculator, the combination cannot take negatives. So you cannot leave your value in this form and use a calculator to quote it. It will be undefined. You can bet on that. You can check. -1 combination 0, it will tell you it is math error. Or half combination 1, it will tell you math error, and so on and so forth. But when you mathematically expand it in this form, it is solvable. My people, are you okay with what I'm saying?
Yes, sir.
Okay, then it means we can say when a is equal to 1, then it means we are going to have it as 1 plus x to the power n. So wherever we see a in this, we are going to put 1 there. So it's going to be just 1. Let me quote it all over again. So 1, I'm quoting it from this second line. I don't want to go to the first line. The first line, we know how to quote it now. So on the second line, we'll have it as 1 times 1 all raised to the power n times 1. Then plus n is maintained times 1 to the power n minus 1 times x plus all divided by, sorry, it's divided by 1 factorial actually, but so all, then the next one will be n times n minus 1 all over 2 factorial, then times 1 to the power n minus 2, then x squared, then plus, so I've written first term, second term, third term. Fourth term is what I have here. This is the fourth term. So I'm substituting 1 in place of a. So we are going to have it as n multiplying n minus 1 multiplying n minus 2 all divided by 3 factorial. A value is 1, so we have 1 to the power n minus 3, then times s value cube, s cube. Then adding the fourth term to it, we have plus n times n minus 1 times n minus 2 times n minus 3 all over 4 factorial multiplying 1 to the power n minus 4 and then x to the power 4. Please, are you all clear?
Yes, sir.
Okay, so we are going to simplify this one. Let me see if I have space so that we simplify. Okay, I don't have space. So since I don't have space, then I'll have to scroll this up a bit so that I write the final information. So writing the final answer, 1 to the power n is the same as 1, right? Because as n becomes large, whatever the index may be, it's still going to be 1. So what's the final answer for this side? What are we getting? 1 times 1 times 1. What's the answer? 1. Good. Then over here to 1 to the power n minus 1, we are going to have it as n times 1, n times 1 times x. So what's the final answer here?
NX.
Thank you, nx. Good. Then we come here. Over here, the whole of this is also going to be 1. The whole of this is going to be 1. So it's left with this and that. So we can write that one as n times n minus 1 over 2 factorial, then x squared. I believe you agree to what I have here.
Yes, sir.
Then we come to this one. We're going to have it as the whole of this here is going to be 1 and s cubed. So we have the factor as n times n minus 1 times n minus 2 all over 3 factorial. Then we have s cubed. Do you agree? So quote the fourth term for me. Quote the fourth term for me.
N into brackets. N minus 1. N minus 2.
Keep on going. Keep on going. Let's go.
3. Divided by 4 factorial. X to the power 4.
Perfect. Then plus dot dot dot. So this is what we term as the binomial theorem. This whole thing as you see here, that is what we term as the binomial theorem. It's a formula or a rule which you can use to write the expansion for any given binomial term, whether it has a negative exponent or a positive exponent or even a fraction. This, as you see here, is known as the binomial theorem. So the binomial theorem, this is it. This is what we term as the binomial theorem. So again, the binomial theorem for rational index is what we have here. So you can see it quoted. You can see it quoted, but I've shown you how this was generated. I've shown you how this was generated. Don't bother yourself about this. Know how to quote it from one term to the other. And remember, always one of the terms must be 1 so that quoting the expansion becomes easy. The first term must be 1 so that you can quote the expansion easily. So in case, so you see I've written something here. Note that if I have a plus x to the power n, you can write the expansion as this before you can use a theorem. If you don't understand how this came about, this is what it means. Watch, because watch, you need to understand and use it wisely. If I have a plus x all to the power n, Mathematically, it means we can factorize the inner terms. Because we want the a to become 1, we can factorize the inner term and write it as a into bracket 1 plus, because we are factorizing the inner terms. So in other words, a multiplying 1 will give me a, then plus a will multiply what to give me x. It should be x over a, so that when the a expands through to multiply this, it will be left with only the x. Then I close the bigger bracket and raise it all to the power n. Again, you bear with me that under powers of numbers, if I have a, b, and they are multiplying all to the power 2, the expansion of this will give me what?
A squared, B squared.
A squared, b squared. Very good. So it means if I have a multiplying 1 plus x over a, all raised to the power n, then it means the n will affect the a separately and equally affect the 1 plus x over a also separately. So we can have it as a to the power n multiplying 1 plus x over a to the power n, and that is what is quoted here. So in case you are dealing with a question which doesn't have the first term as 1, then you can write the factor form of it before using the theorem. Remember, this will be maintained, and then the theorem will affect the second part of the factor. Please, is it clear? We have some few minutes to go, so I can take one example on how to use a binomial theorem for rational index or negative index and so on and so forth. Can we take one example?
Yes, sir.
Okay, so taking one example, now use the binomial theorem to expand and simplify the following. So ideally, you are using the theorem to work out this. You are fortunate you are being told to use a binomial theorem. Sometimes they will ask you to expand this as far as the s cube term without being told what to do. You should know how to write this specifically here in other forms. You should know how to write this. This one is in a form you can easily work. It's in a form you can easily work. But this and that, you need to change them to write them in the power forms. In the power form, this here, the a can be written as 2 multiplying 1 plus 2x to the power negative 1. This is the index form of this question. Then again, coming here, the d part, it is 1 multiplying 1 minus 2x raised to the power negative half, because the square root is actually a negative, sorry, the square root actually is half when you write it in a power form. But because you have 1 over that, it becomes a negative exponent value. So take note of this. Please take note of this. Okay, so let us solve just the first one. Yeah, let me solve the first one, which is the a. If there is time, I'll work out b, then you do c, and then d. But I've shown you how to write the d in the power form. So working out this, 2 into bracket 1 plus 2x raised to the power minus 1. Then it means if you become more professional, then you can go without quoting the formula. But for now, if you are not professional and you want to use the formula to guide you, then before you start, you can quote the formula so that you do your substitution easily. Quoting the formula, 1 plus x all to the power n. Yes, we are writing up to the s cube term. What will be the first term? The first term is what?
1 plus x to the power x plus 1.
The first term is actually 1. The second term is actually nx. The third term was n times n minus 1 all over 2 factorial and then x squared. And then the fourth term, which is the s cubed term, is going to be n times n minus 1 times n minus 2 all over 3 factorial then s cubed. So this is the expansion up to the x cubed term. That's a binomial theorem for that. So having our question as 2 multiplying 1 plus 2x raised to the power minus 1. Then the question now is the 2 is not part of this. So what is going to be our n value? N value is going to be what? So n value is -1. What is our s value?
2x.
So s value is 2x. So that's going to give us 2 multiplying, then we just substitute our expansion in here because this 2 is out. So 2 multiplying, then we have 1 plus, we've seen the n value as -1, our s value as 2x, so 2x plus n value is -1 times -1 minus 1 all over 2 factorial. Then x value is 2x
2x.
all squared plus n value is seen as -1 times -1 minus 1 times -1 minus 2 all over 3 factorial and then 2x all cubed. We are actually ending there. Then we close a bigger square bracket. Simplifying further, 2 bigger square brackets. This will be maintained as 1, but here becomes -2x.
Minus 2x.
Then here will be -2 will be here. -2 times -1 will give us +2. +2 all together divided by 2 factorial. What answer is left?
1.
1. And then 1 will multiply 2x all squared, which will give us 4x squared. And that is going to give us plus 4x squared. Are you clear with the simplification of what I have here?
Yes, sir.
Good. Then plus, we go to the last term. Here will give me -2. Here will give me -3. Here will give me -1. So -1 times -2 times -3 all together will give us -6. Do you agree?
Yes, sir.
And we've seen that 3 factorial is the same as 6. 3 factorial is the same as 6. So -6 divided by 6 will give us a final answer of what? -1.
-1.
And 2x cubed is the same as what value?
8x cubed.
8x cubed. So in other words, we are going to get -8x cubed. -8x cubed plus ... So now we can expand the 2 through. Expanding the 2 through, it is 2 times 1, which is giving us 2. 2 times -2x will give us -4x. 2 multiplying that will give us plus 8x squared. 2 multiplying that will get what? -16x cubed plus ... But since we're told to write it as far as the s cubed term, then you can write the answer as this, excluding the plus ... Please, am I clear?
Yes, sir.
So it's all about knowing how to use this tool very carefully, knowing how to use the tool carefully. All right, our time is actually up. So I don't know if you can spare me some few seconds to work out the B, and then we can call it a day, because I can't do only one example and then leave the others. So let us do the b together and then we call it a day. So doing the b together, so we should use a binomial theorem to write the expansion for this up to the s cubed term, So ideally, please watch this carefully. I've told you, I don't want this to be a hunt to you or horror to you. No. So writing the binomial theorem for 1 plus x to the power n up to the s cubed term, we saw that the first term is automatically 1. The next term will be what? The next term will be what? Are you sure it is nx? The next term will be what? Then the third term will be what? Okay, so that's where it ends. So considering our question to be 1 minus x all to the power minus 2, then we must ask yourself, what is our end value? From this question, end value is what?
-2.
What is our x value?
-x.
It's negative x. Per this, x was positive, but per the question, x is negative. Are you clear?
Yes, sir.
So let us substitute. So this is going to give us the 1 minus x all raised to the power minus 2. Using the theorem here, we're going to get it as 1 plus end value has been seen as negative 2 multiplying s value, which has also been seen as negative x, plus n is negative 2 times negative 2 minus 1 all over 2 factorial. Then x value is negative x all squared, plus minus 2 minus 2 minus 1 minus 2 minus 2 all over 3 factorial, then negative x all cube, plus dot dot dot. Please, are you clear with whatever substitution I've made? Are you okay?
Yes, sir.
All right. So let's simplify. Simplifying, 1 will still stand as 1. Minus 2 times minus x will give us what?
Positive 2x.
Positive 2x. So it means we're still going to have 2x here. Then over here, minus 2 will be maintained, but this will give us negative what?
-3.
So negative 3 multiplying negative 2. What answer do we have?
Positive 6.
So positive 6 divided by 2 factorial is the same as 2. What do you have?
3.
3. So we have positive 3 here. How about this side? Negative x all squared is what?
X squared.
So we have x squared. So this is what we have for the whole of simplification to this. Then over here, I wouldn't write the operational sign, but let us simplify. This will be minus 2 maintained. This will give us minus 3. Here will give us minus 4. So it's like minus 4 multiplying minus 3 multiplying minus 2. What are we getting for the numerator?
-24.
Minus 24. And then 3 factorial is the same as what number? 6.
6.
So minus 24 divided by 6, what is the answer?
-4.
Minus 4. Are you sure?
Yes, sir.
So it is actually minus 4. But minus s cubed Minus x all cube will give us minus x cube. I hope you agree to that. And the whole of this is giving us minus 4.
Yes, sir.
The whole of this is giving us minus 4. So we have minus 4 multiplying minus x cube. What's the final answer?
4x cubed.
So we have positive 4x cube plus dot dot dot. But for the sake of writing up to the x cube term, then we can leave our final answer as 1 plus 2x plus 3x squared plus 4x cubed. And that is it. Please, are we all clear?
Yes.
All right. Thanks so much
Yes,
for
sir.
joining the call. I'm privileged having you. And I know we are going to have another time to dive more into binomial expansion in our next lesson. And I'm so grateful that you are subscribing to my YouTube channel, Math Made Easy with PDY. And trust me, I'm so happy. I believe you are getting the lesson so easy and understanding. I've shared the notes with you. Please go through them and then be confident of yourself. Also reach out to others to help them. And together we are all going to make math fun to understand and learn. Thank you once again and have a lovely day. God bless you. Bye-bye.